I'm going to be teaching you how to write concluding statements for following chains of reasonings. So let's get to it. So these basically state if A then B, or for example the second line, what this says, it says if D then not C. So what basically means that it's saying if A then B. This is your conclusion and this is your hypothesis. This whole entire thing is called a conditional statement. Now, for conditional statements, you can also have inverses, converses, and contrapositives. But I'll dive into that in a different video. So we're asked to write a concluding statement for each of the following chains of reasoning. So to start off, we need to find a hypothesis or conclusion that is only one, at least that's singular in all four of them. By what I mean by that is that we can't start our chain with A because two of the following conditional statements already have A. So our only choice that we can start off by is D or F. But for now, I'm going to pick D. So that would mean, so now we just chain them together. So D would mean not C. Not C would equal or conclude A. And then A would conclude to B. And B would conclude to F. So our final answer is if D, then F. Now you might be thinking, what happens if I start with F? Well, we could also do that. Well, what happened is we would get the same answer. If you don't believe me, you can just try this. You start off with F, then it would be B, then you would have A, then you would have not C, and then because we already had A, it would then be D. So it would be if F, then D. So both of the statements are just inverses of each other. Okay, so now let's move on to the second one. We have to choose one that is not common in both. So I'll choose S. So if S, then R. If R, then Q. Now we run into a problem quickly. This says we have Q, but the other one is not Q. So now what do? Well, we can't just automatically put it as P. So for this, what we have to do is change the P, or we have to do the contrapositive, which means we would have to do the inverse and then the converse. So the converse first would be if not Q, then P. That's the converse. And then we have to do the inverse of the converse to get the contrapositive. So then that would be if Q, then not P. Now you might be asking why I just did that much work. Well, we can't just change the Q to the not Q to a Q because the contrapositive is the only one that variation of the original definition that we can trust. So we're left with the equation of Q, then not P. So that would be not P. So our answer is if S, then not P. Thank you for watching.